So welcome to this session on Glamorous Toolkit. We're going to start a series of such live sessions in which we introduce people to what Glamorous Toolkit is, and in particular, what it basically enables, because it's, we are saying that it enables this new practice, which is called, we call moldable development. And we want to give people a bit more hands-on experience as to what that means. So, and this is the very first session in this area. So basically, this is what we see when you're downloading a Glamorous Toolkit from Gtoolkit.com. You see here a couple of yellow signs that prompt you to starting with it. And the very first yellow sign is taking a tour, and this is basically an interactive means to go through what Glamorous Toolkit is, and it is delivered directly in the environment. So Glamorous Toolkit is developed by Think, which is our company, and I think our main goal is to make the inside of software systems explainable. On the one hand, this is what occupies the largest chunk of development. Developers try to read code in order to figure out what to do next. But at the same time, it's not a very explicit activity, and we think that we can do much better by reimagining this part of the development process, given that 50% or more of the time means that this is the single largest expense that we're going to have as developers. So what Glamorous Toolkit is the very first materialization of what we think a new kind of a development experience would look like. Now, Glamorous Toolkit goes a long way back. It's about a decade, and it went through multiple versions. And the version that you are seeing now is the one that we call the beta. We are deeming it as usable enough, basically, for people to start playing with it. Okay, so what exactly is moldable development? Well, for a long time, we used a specific way of looking at systems, and that specific way was primarily focused on the content and not on how we are looking at the system. Specifically, let's take, for example, what's the smallest tool that we have in a development environment? And the smallest tool that we have in a development environment is an inspector, because the object is the smallest unit that we have in a system. And so this is basically where we started from. We wanted to start from, and I was saying that Glamorous Toolkit, we spent about a decade working on it or thinking about it. And of that decade, maybe 70% of the time was spent on rethinking how we deal with an individual object. Now, why a single object? Why not start, for example, from the editor? Well, because software has fractal-like properties, which means that on the one hand, which means that whatever we have at a certain level of abstraction, we're going to find similar problems at higher levels of abstraction. So in order to, in these kinds of systems, in order to affect the broader scope, you have to affect the smallest scope. So the focus, for the longest time, our focus was, how do we fundamentally affect how we relate to one single object? And so let's look at what do we mean by that. So here we see 6 objects, six different objects, and all inspectors in the world, except of one, show all of these objects exactly in the same way. That is, here are the variables and here are the values, right? Because the inspector is being defined as the tool with which to, that shows you the interior of an object. But if you want to turn it around and say, we want a tool that shows us how to understand an object, then all of a sudden the inside of the object are secondary in interest. So if we look here at this representation, the interesting thing about it is that it's applicable to all objects in the world. And that's interesting because it allows us to implement it once and then reuse it many, many times. And there used to be a time when tools were expensive, and this kind of an approach made a lot of sense. But nowadays, the question is this representation meaningful? For example, if I look at these 6 objects, can I see the difference between them? Can I distinguish how they are different? And the answer is no. So if I, for example, if I stay like half a meter away from it, there's no way for me to understand or to make it, to really distinguish between whether or not these objects are somewhat similar or really different. But on the other hand, if I change the view, if I only change how these objects are being presented to me, I can form mental models that are completely different. So for example, here I can see, okay, this looks like a fraction. This looks like a folder, right? So I can, especially if I can scroll through it, this looks like some sort of a picture. This looks like a Bezier curve. This looks like some sort of an algorithm. And yes, this looks like some sort of a data structure. And so what's interesting here is that the only thing we have changed, we haven't changed the object. We only changed how we look at the object. And by changing this, we have enabled new kinds of thinking, new thoughts that were previously not accessible. And that's the interesting thing. And that's what the focus of moldable development is. There is this layer in between we humans and the system that we're looking at. And that layer is provided by the environment through which we are experiencing our systems. And it is this environment that is essential, because the difference between this view and that view is literally only the environment. The content didn't change, which means that we can't treat the environment as being a secondary citizen or something which we just take by default. It means that we have to pay very explicit attention to it, because as I was saying at the beginning, reading or trying to understand the inside of our systems to figure out what to do next is the single most expensive activity we have. So if we can improve this one, let's say with an order of magnitude, well, then it can probably have a very significant effect. So the other thing that we are learning here is that there is no single perspective from which to look at anything in software. Because if you look at it like that, software is immaterial. It's just data, and data doesn't have a shape. But we as humans, we need a shape to reason about anything. We need a very concrete syntax. We need a very concrete form. And this form through which we are experiencing our systems is provided by our tools. And there is a science behind these tools, and what Glamorous Toolkit is exactly that. It's an environment that makes this science practical. And then, so given that there is no single perspective, no dominant perspective on software, it follows that the tools, the environment, should not assume a specific perspective. So if we look at our 6 objects, but now in the full inspector, we want the inspector to not assume that all our objects should look like this. We want the inspector to say, well, you object, what kind of a view would make sense for you? It's a simple change in the end, but it has dramatic effects. So here we see, okay, the fraction can say, I want to be shown as a preview. And there is a preview over here that shows exactly this. Here we have actually 2 instances of a file reference, the file reference here, a file reference there. But interestingly, because this one points to a folder, this file reference over here, we can see a view of the contents of the folder. On the other hand, because this one points to a picture, we can see the picture. But because both are files or file references, they both show us the contents on the path, because that view makes sense everywhere, or for all file references. And that's the interesting thing, right? We want our tools to mold, to change their shape based on the very specific instance that we are looking at. So not a generic thing that is hard-coded, is being imposed to us, but the other way around. We have something that we look at, and it's at that time, it's ideally even at runtime, that the tool should decide how that thing could potentially be exposed to me, the human, and ideally me, the human, would like to choose how that interaction should look like. And so, and the same thing happens here. And then we can have many of these kinds of presentations. And we're going to go into that. So, for example, here we have one single object, which is just basically it's a piece of text. And the text can be shown as an editor over here on top. We can see the data structure that is behind it. So this is a rope data structure, and we can see there are different kinds of attributes associated with the piece of text. We can look at it as if it's a string, and then here, if I click, for example, here, I can see here on the left the position on the stream, right? So the index, and then as I click here, this pointer changes there. This is very useful, for example, for parsing, right? So let's say that I want to know, is this going to be, is this the CR-LF? And then I can see here there's a CR over here. So no LF in this case. And similarly, a different presentation over here is just a serialization. So for debugging purposes, we would like to, sometimes we want to see some internal representation, or maybe we want to be able to reproduce an object for a later state. And all of these views, they make sense, but for different perspectives. They don't necessarily make sense at once. And that's the thing. We don't have to choose a perspective. And that's basically the essence of moldable development. Okay, so how does it then look like? Let's go back. You can go ahead through the tour. It gets you through our components. So let's go back here. Let's start with the playground. So the playground over here is the place where we start to basically play. It's in other Smalltalk environments. This is called a workspace. So let's start by just simply investigating the current file reference that points to the current folder. So this is a file reference that points to a folder. I can see contents over here, which means now that I can maybe double click on a folder, and then immediately it flowed to the right. And that's interesting here because something interesting happened here. So if I go back at the beginning, when I executed this piece of code, I got this inspector. So basically I got an object, and the inspector was there to say, well, this is an object. How do you want to appear? And then they ask the object, and the object says like this. But when I click here, I also get an object. And I get the same inspector or same kinds of tools that appear. And then what's interesting here is that it means that clicking and programming, they're the same. They are not really different, which means that we can start to be able to combine them in any way we want. So let's say, for example, if we say here, I'm going to open here a playground from the bottom, and this is now an object playground. And this object playground here, if you can say self, I just want the directories. And if I execute that, what just happened here is I got a connection with just these directories over here, which means that if I am clicking on source, I will get an object which then knows how to print itself. So again, the interesting part here is that whenever the UI stops, we can always go and program our way out of a corner and continue the conversation. There is no predefined set of conversations that you can have with your system. There are always many. And that's again, another perspective. So, but maybe let's do something that is more, this is more interesting. So here, for example, we have a source, and this is actually a JavaScript system. So one thing that we can do here is I can go and look, this is a JavaScript file now. And interestingly enough, because this is a JavaScript file, it shows me as with JavaScript syntax. But behind it is represented as an object of the type file reference. Equally well, if I go over here, let's say I can have here another file, and that looks like, it's just a JavaScript file. And so now what's interesting here is that I'm being presented with a piece of text. But that piece of text is, I can always try to manipulate it maybe at a different level. So let's say, for example, we are interested to reason about this, and we want to understand how the flow or how the absent syntax tree of this file, how the language is being represented in this file. So what I will do here, I will say, well, because I already have a parser for JavaScript in my environment, I will say, I simply want to parse these contents over here. And if I'm executing that, what do I get? Well, I get an absent syntax tree. Now, an absent syntax tree is really a tree. So like the tree, I have here just import declaration node, I can have the imports and so on. But if I look at it here, this is a different presentation. It's a little bit more interactive. And as I click here on the left, I get highlighted very much in the same way as I was doing it with the string, where I clicked on the string and I saw the stream on the right, or two different representations connected to each other. Here I'm doing it the other way around. So, and if I want to learn, for example, how do I query my JavaScript? Maybe because I want to do a lint rule or something of that nature. I can very well, sorry. I can very well do just that. I can use this kind of tool to basically take a look, how is this tree is represented? And at the end of the day, querying code is just, in this case, it's just a tree. Traversing a tree is not a big deal. So as long as I understand what the tree looks like, then all of a sudden the problem that would appear to be very, very complicated becomes rather simple. So, and then the other way around. Now, here's the question. And this is we think that this stays at the core of how we think about the environment. If you would have, how do you name this tool? Because as I said, we were just in something which we call an inspector. But if you look at the at the use case, I was doing here a query, and then afterwards I have a folder, and I'm navigating through folders. And at some point, I get to a file. Now, this is an editor with syntax highlighting here, so I can do things if I want to. But at the same time, with just on the next pane, it becomes an analysis tool, a deep analysis tool that looks behind the scenes of what I'm looking at. So it's very difficult to describe this tool because we are used to describing tools in terms of silos. An analysis tool is going to be different from a file browser tool, which is going to be different from an editor. Because we were trained for a long time to go to the tool to do some activity. But because development is so software is the most contextual thing we've ever created as human species. We can create enormous complications at very small scale, basically. Because of that, we cannot predict the specific actions or the specific problems that people will have. And as a consequence, we cannot provide clicking tools. And so this idea that we have to decompose the activity based on tools is simply wrong. So what you're seeing here is a different decomposition where we have a problem, we look at it, and then the tools come to it. And it's not the other way around. So it's a completely different, it's 180 degrees different perspective on what tool compositions could look like. Okay, so this is one aspect of this, but let's go a step deeper. So for example, here I take the same Zooniverse mobile, and in this case, I will be building a slightly more complicated model of it. So one of the areas of applicability for Glamorous Toolkit is something we call software assessment. So the idea of looking at how software is composed rather than how software looks like from the outside world. So here, for example, in this case, we're doing it's just static analysis. So we built a model. This universe is actually a React native application. So on top of JavaScript, it has a React, which means that if you're looking at React, so if I go here, let's say in the sources, and I look at components, and I see here this checkbox or the button, right? This is what we see here. This is JSX, and that's the definition of a component. So if we look at JavaScript alone here, we're going to miss this semantics, which are highly important for a React system. So this is why the importer here, we built a little importer that takes, we have a JavaScript JSX parser over here, and it builds a model out of it. So one problem that we see people encountering when they're building, for example, React applications, is this idea of dependencies between components, and very often people go into cyclic dependency there. And yeah, while we were playing with the system, we very soon, in a matter of days, got to that kind of a problem. We were asking ourselves, so how do these components relate to one another? And so how did we deal with that? Well, how do we deal with absolutely every single other problem? That is, every time we have a problem, every time we have a question about a system, we start from the question, and then we say, how would a perfect tool look like? And then we're going to build something towards that perfect tool. Probably not going to be the perfect tool, not first, but it's going to be enough to improve over the situation of having no tool. So here, for example, now if I have, first of all, we wanted to figure out, or so have first-class entities which represent React components, and in this case, they are represented as objects. Here I have a group of these components, and if I have a group of these components, I can simply go and do this, which basically gives me the dependencies between the components. So here, if I look at the render button over here, I can see that this one this is the source code of it, right? This is the render button, and somewhere here, right, there's a connection, there's a dependency between the render button and the button. And I can see that one also here, render button includes the button, and also if I click on that arrow over there, it will point me to exactly that one. Now, the specifics here are not necessarily relevant. I just wanted to say here that this is one area of applicability of Glamorous Toolkit. Already Glamorous Toolkit comes with an extensive software analysis and a language workbench underneath, which means that you can use it to go and reason about systems built in any other or in other kinds of technologies, and very, very quickly. And the other part of it is that you can build tools, not that are, so for example, here we have a tool that is language specific or technology specific, in this case, so framework specific. But what we're thinking that the future of the development experience goes towards is system specific tools. So not language specific, not even framework specific, but system specific. And Glamorous Toolkit itself is the first extensive use case of what do we mean by a system that is basically powered by a tooling that is highly geared to the kinds of objects and behavior that defines the system. So what do I mean by that? So let's go back here and say, well, let's say we go to the file reference again. If I inspect that one, I want to see how, let's say, how this print over here, which is just nothing, does nothing else but print string of that object. So how is this implemented? So if I alt click there, so I just pressed alt and I clicked on print. What happened here is now I get an object which says this is the method definition. So this is like a meta object when this meta object that represents a method in this case in the system, and the method is implemented in the class called object, and the method is called gtprint4. And the only thing this does is simply says, well, given this view, I want a text editor there, and I want the title to be print, that's print. I want this priority, and I want these contents inside the text, and that's it. So essentially, in this case, for the inspector alone, all of these views are defined through methods that are basically implemented in our case, or in this case, by every object, but the object that we're looking at. So essentially, it's kind of, you can think of these ones like toString, in, for example, in Java, instead of, because this is the 21st century, you can say toWidget. And because, you know, following the moldability principle, you don't want to have just one representation. So instead of toWidget, you have two widgets. So essentially, that's all what it is. This is a method that knows how to print on a stream, except that this stream is a visual stream, so it accepts widgets. That's it. And then we have different kinds of compositions on top. Now, so this green thing over here, this is called a pragma. So for those that don't know Smalltalk, this is the correspondent of an annotation, for example, in Java. So let's say I want to learn now, how many of these extensions do I have? As I was saying, we are building, or we think that the future of development is going to be system specific to the future of development experience. And that means that every time we don't have an experience that suits our environment, we want to build it. And this is exactly the principles that we are using whenever we are creating Glamorous Toolkit itself. So I just copied now this GT view. And what I want now to do is I want to write a query. And this query is going to say, well, I want to find out all the pragmas that are called GT view. And when I execute that one, I get a search pragmas filter. And so this is like a search object, basically, that knows how to print itself. Now, how does it print itself? Well, it prints itself through live editors. So it's just a bunch of editors over here. And these are all live. So we can go and modify code if we want to. Essentially, this is a scoped browser over here. And we basically get here, it's on the one hand is the result of a query. On the other hand is something that we can go and act on right now. But what I wanted to say here before we go any further, and to back up this idea that Glamorous Toolkit is already built using this moldable development approach, is that there is this tab over here which says metrics. And this here, it says that there are 1,025 different methods in this filter. Now this filter, as I said, this represents all the extensions that we have for the inspector in a stock Glamorous Toolkit. And we have more than 1,000 of them. That means more than 1,000 different plugins, except that these are really, really, really tiny plugins. They're so tiny that if I look here at the lines per method, I have 11.7 on the average. Now, if I take away the first two lines, it means that basically I'm writing less than 10 lines per extensions on average, obviously. So this becomes interesting because the idea here is that in order to economically, to make this idea of moldable development feasible at all, it follows that the only way in which this can become feasible is that that the cost of a custom tool must be very, very small. And that's exactly what you're seeing here. And we are not creating these, 1,000 extensions just for marketing purposes. These 1,000 extensions were literally created out of engineering need. And we can now say that this is a way of programming that is distinct and it's orthogonal to the kinds of other kinds of decompositions of programming. For example, a decomposition would say, well, I'm going to program object-oriented versus functional, for example. This is something goes orthogonal to that. Okay, so that's a core idea, right? So again, what's this tool that we have right here? Because I just wrote a query over my code in the playground, and then I'm editing code, my code, in an inspector. right? So it's all like all of those decompositions that we knew about before, they're, they're no longer really necessary or no longer relevant because they're so limited. The possibilities of creating highly custom experiences are many fold larger than the simplistic silos decompositions that we are trained with and that our vendors are training us with. Okay, now this also gets us to this to the editing. So we actually in the history of Glamorous Toolkit, we literally built the editing tool at the very end. Like this was the very last thing that we have created, because we wanted to push ourselves to rethink things without starting from from assumed from pre-existing ideas. So, for example, if you look at a typical development environment, it already has all sorts of bells and whistles, and has global menus, and there's always something on the left with the index of things. And in our environment, this doesn't exist, or it's not the first thing that you're seeing. You actually can see it, but it's not the first thing. So, for example, here, if I go to a class, let's say if I click here on abstract file reference, I go to another tool. Now, this is not an inspector anymore. This is called it's called a coder. So this is a place where I am manipulating static code. And if I zoom out, if I maximize that pane, that's when I see this index, because that's an interesting perspective to have when you really want it. But that's not the default thing, and it's definitely not the first thing that you should see. And the other thing to see here is that the editor is something you get to. It's not something you start from. Right? Editing usually, like if you think about when do you edit? Ideally, you edit after you learn why or how, and not the other way around, right? So, and the other thing about it is that I was starting by saying that reading is the most expensive or is the most pervasive activity we have in software development, but we actually don't really talk a lot about it. Right? We don't really challenge that we should be reading a lot. And through moldable development, we do challenge exactly that part, because the most part of that reading is actually not a reading problem, it's a search problem or is a visualization problem. So this is the code there. So we do have a code there, but what's interesting also about it is that it has these little tiny things here, which then allow us to look inside. So these are like these methods, right? Because again, because we wanted to decompose, create the larger tools. They're always made out of tiny tools. They are composed through some operators. And whatever we have as a predefined tool is just a composition. And you can go and create your own. And everything about a software system, everything has to be moldable, has to be changeable. There's no single perspective that should be hard-coded. Right, so, and then even here we have this type of abilities. So here I'm seeing a method and it has this triangle, I can look inside. So I have these editors over here that allow me to drill into a piece of code without actually having to change context. And we've built a whole new graphical stack just so that we are able to do this. But that's an important thing. And so, for example, here it's an interesting debate. People are saying, should a method be long or a function? Should it be long or should it be short? And then you have many of those. But if they are short, people are saying, well, it's hard to follow because it's always you have to switch context all the time. But what if this is a tool issue? What if this is not a design problem, like a code design problem, but a tool issue? So what you're seeing here is because we can put things together in the same place, I don't have to make that trade-off. So again, just because we are providing new kinds of operators now at the level of the environment, enable new kinds of ways of thinking about the inside of software systems. And then, of course, these types of principles of moldability applies everywhere. So, for example, it applies to search. Here I have Spotter. This is our global way of searching. So if I now say, I want to understand, I was just looking at this JavaScript parser, I can see here, this is a um, this is a class, and as I search through it, I can see that there are these little things over here, and that those little things are actually just little operators that actually would just ask the global object, the global spotter, to say, what can you search? And that's not hard-coded either. Just like how an object knows how to view itself, it also knows how to print itself. Now, if I go to the JavaScript parser, I can see, well, there was this way of looking at it, which shows me these types of things. But the thing is that this JavaScript parser is actually generated. So this whole Smalltalk code that you're seeing here is actually not really relevant, and I have no idea what it does, because there's a lot of mumbo jumbo here. But if I look at it like that, if I look at it as, at the logical level, then I can start to have completely different, a different way of manipulating this. So in fact, this is the second language that we are hosting in Glamorous Toolkit that is not the basic Pharo language that we're using, is the language with which we're defining all the other languages. So in this case, or the support for all the other languages. In this case, this is called SMAC. Comes from Smalltalk compiler. And notice here how we're having similar kind of ideas. So this is like a production over here. I can see here, this is an expression. And this, this here, right? I can expand that one and I can see another one, and I can do that. And I can do it all the time. And what's interesting about this is that this triangle over there is added by the syntax highlighting. So if I type here and I get completion, if I type, then the triangle appears and I can just simply look at it, and it's all happening dynamically. So this is an interesting thing, because now we are saying, this is like what we are normally thinking about language workbenches. But this, the idea goes a little further in that we think, well, what if you don't have a definition for your language? What if you just have a library? Well, so here I'm gonna search for something called a baseline. So baseline is the tool that, it's like that composes what gets loaded and what makes Glamorous Toolkit. So here I can see a view over that one. So this is the map of all the projects that make up Glamorous Toolkit itself. And if I look at how it is being defined here, there's this baseline method over there. And here I can see, well, there's this spec baseline. This is normal plain Smalltalk, except that here we have a little completion and we have this expander, not for a method, but for a string. And if I expand that one, it takes the string and then it searches for a class which is called baseline of Gtoolkit clipboard, the same string as there, and then presents me the text here. And so what's interesting here is that the coder allows me to define little plugins that get activated as soon as I have a pattern for this specific library. It can be a very small extension. It can be shipped with the library, and then the environment adapts simply like that. Okay, so this is basically a very core screen overview of Glamorous Toolkit. Now, going back to the practicalities, how do you go about learning it? So looking at the slideshows over here is a very nice way. We think we're gonna add more of these ones. As you notice, when you go into a slideshow, it's all interactive, and you can, like do things with it and learn by doing. And the lessons that we want you to learn about the environment are being delivered right into the environment. So if the question is, where do I find things about the environment? How do I learn things? A lot of these answers are actually already in the environment, and we're going to add more of those. Another source of a place to start are these documents over here. So these are live documents, and here, for example, you see the same view that I showed you before, and they are, they can be editable. Here, there's a markup language behind it. We're not going to go there, and this is all interactive, so you can click on any of these, and then you can basically browse your whole environment as if it's basically a large wiki. So, and finally, here on the top right, there is something where we're inviting you to to get our posts, and this is basically a live post that comes from blog.think.com. You can see it also, you can see those on the web page, but you can also get them. You can also get those kinds of blog posts right into your environment and basically learn from it like that. So that is a short overview of what Glamorous Toolkit is and what moldable development is. And let's stop here and go to the Q&A session. So are there questions? Questions?
So
No
Tudor,
question?
at some point, you and I had a phone call, and I remember you showed me some way to browse Java code. Is that also built into Glamorous Toolkit, or is that a separate library that I need to install or something?
So for Java, specifically for Java, you have to go, there are two ways. So if you just want to browse, Java, like just the parser, there's a Java parser right here. Java parser. And I can see this is basically similar to how the JavaScript parser is being defined. So this is the if statement over here. But if you want to build the more complicated model, at the moment we are relying on an external library, which is called JDT2Famix. And that's something that produces an intermediary file that we can then load to reason about our systems. Does this answer the question?
Yes. I think an interactive session on that would be something I would vote for.
Okay, we will tackle more of these later.
Yeah, thank you.
So there's a question here is about what's the future? What's the plan for the future of GT? Do we have a public roadmap? We don't have our public roadmap is that we want to go to the first version. The way we work is that we are guiding. We're basically saying we have a problem and we're going and finding possible solutions to that. We don't necessarily promise specific results because we don't know how those should look like in the first place. There's a lot of discovery that went into the creation of Glamorous Toolkit, and we think that there is a lot of discovery to happen in the future as well. But what we do intend to do, and that's why we opened up the Discord community, is to engage in very active conversations. And our plan is more, rather than promise long-term plans for how things will develop in a year or two, rather than that, we want to favor quick reactions. So engaging with the community and reacting to the needs as they appear. So there's another question here: is GT only available on Faro? And how Smalltalk? So how much it depends on Faro, and with the goal of porting to other Smalltalk systems. For practical reasons, it's going to be not a. So our dependency to Faro we depend on the language and the core libraries, but we do not depend on on anything on the user interface, because we have created a whole new graphical stack. So everything that you're seeing rendered here is actually is built pretty much from scratch. Not pretty much. It is built from scratch, and underneath we are relying on libraries that are coming with with web browsers, for example, Skia for rendering, and Glutin as a window hosting. But nevertheless, our implementation is compatible with Faro. So here, for example, you have a live document that describes how, what's the relationship between Glamorous Toolkit and Faro. And out of the, so for example, right now, this image here has more than about 1 million lines of code. And of those, half of it comes from Faro and half of it comes from the code that we are shipping with Glamorous Toolkit. And in Glamorous Toolkit, we have the core of it. And then we have all these parsers for all sorts of languages, like 12 languages, XML, and this high-level model for reasoning about other systems, like this is what we call FAMIX. And so, but these are basically, you can think of them as plugins. So the core of Glamorous Toolkit is these 275,000 lines of code. And of Faro, half of what ships today with Faro, we are not, we don't rely on. So it's still there for backward compatibility reasons and for as a transition period, but it's not essential for anything, like it's not used in anything that you have seen, for example, in the demo today. It's what we call the Morphic world. And you can access it from the main page here. That's basically you're going into that graphical world of Faro. Other questions?
So another question is, if you have, it's also related to this, if there is an interaction between Think team and Faro community.
Oh yeah, so the way we think about, so we want to be, or we are until now, completely compatible with Faro, which means that Glamorous Toolkit essentially is, we take Faro and we just load code into Glamorous Toolkit. And then we ship, that's the distribution of Glamorous Toolkit, which means that Glamorous Toolkit is 100% compatible with Faro logic. Some of it, if you rely on the old graphical parts, then they will not display in the new world. But if you have any other logic, let's say server logic or any other logic like algorithms, they will appear in the new world. And so the way we see it is, we look at our work as being primarily on rethinking the environment. So the graphical part of it, this is where we started from, this is where we're focusing on. And so it's the graphical parts of it, and plus all the connectivity to the outside world, be it languages, or being how do I connect to some various kinds of other formats. And and we do collaborate with the Faro community, and we do contribute that to the Faro community. For example, we are using the VM, and we're using so the VM is built within even the broader context than the Faro community, which is called the Open Smalltalk VM. So we're contributing back to that one, and we're contributing back to the Faro core when needed. So there is an interaction, and we do want it to continue, of course.
The next question would be, is there a list of shortcuts, keyboard shortcuts?
That's a super cool question. Is there a list of shortcuts? In fact, right here in this in this blog, discovering coder shortcuts. So if we look at this one, at the moment we don't have this list of shortcuts is not available on the UI. But remember, this is a system that you can introspect on. And so the answer should be available somewhere there. So here, for example, if I have a coder, like a method coder, this snippet that shows me just that, right, where I can just start here a method, I can start typing there. So if I'm inspecting that, I can see here that I see here key bindings, right? And what's nice about it, right, is that I can go there and I can see what's this implemented in. So from this blog post that I just downloaded, I executed a piece of code, and so this piece of code, and I got a result, and I can look at it. And here's a list of, right, this is the method coder, which is an instance, and I can see here the key bindings for this specific instance. Because remember, key bindings can change dynamically because they are plugins that plug in. So it depends. Maybe for one method, I'll have more key bindings than for the other. Now, of course, the core ones will be the same everywhere. So it would be ideal to have a list of those, and we will, except that this is not available at the moment. But they are available because we needed to debug our own code. We needed to see, well, what are the key bindings that are active at the moment? And so this is how this this view appeared. And so here, what's nice about it is that if I click on this specific, like for example, if I press Command N, I can see I'm going to browse references for this, for the target over here, right? So I hope that answers the question. Does it answer the question? I hope it does. So, other questions? I can see that there are some questions also on the group Zoom chat.
So a few of the questions from the group are, how are you funding the wonderful work you do?
Ah, we love the wonderful part, yes. So how do we fund our work? That's a good question. So Think is basically, until now, is completely self-funded, and we are basically earning money through consulting, which means that we go and we solve very, very concrete problems. And those problems can be, generally, they are split into two classes. On the one hand, we go and work with legacy systems. So companies that have maybe large systems or old systems, or large and old systems, and maybe they want to split it into whatever, or they want to migrate it to something, or they want to put it in the sky or the clouds or something like that. And they might not know how to do that. And the thing is that every time we go in these companies, we ask them, so do you have a picture about your system? And they say, yes. And then we say, well, can you bet your salary that the system is real? And they say, no. So now, of course, you don't know what to do with it, because if you're going to use that picture about that system to reason about that system, you're not in a very good, you're not starting from a very good place. So what we're doing in these type situations, we're actually building very, very concrete custom tools specifically for the problems and for that system. And then we're using these tools to reason and to also to guide afterwards long-term, for example, migrations or refactorings or and at the same time, we also, because what happens here, the other part that happens there in legacy systems, the people are always perceiving those as being just costs. And they're always, frowned upon as, oh, I really do not like to work there on that system. And that's not a good thing, because legacy should be beautiful. It should be, it's what got us here. So there's a lot of value in it, and there should be a way to look at it and see beautiful things. And there is a way. And just like with the object, right? We didn't change the object. We just changed how we look at it. And there's a complete new world that opens up just by doing that, just by changing how you look at something. Of course, you want to change it. Of course, it will have lots of irregularities that you want to streamline and strengthen and so on. But so these kinds of projects, we are taking things that people are considering to be very expensive to modify, maintain, and evolve, and turning them into something that is manageable, and then people can start to look at. The other thing that happens there is that simply by showing how the technical things look like, business start to engage with technical people. And you can start to shape the conversation, not so much as, software as being a cost, but more, on a legal footing, like saying, well, software is some sort of an investment. So this is one of those. And the other one, the other side, so one time we're working with legacy systems. On the other hand, we're working actually with startups, and we want to help them innovate faster. How do we do that? Well, basically by doing super aggressive prototyping, where you get the feedback not so much on the whiteboard, but you get the feedback directly in the environment, but in inspectors. And we go so far is to actually work with a startup and then help the startup pitch investors and build an executable slide deck, just like you saw before, an executable slide deck that actually shows a bunch of inspectors and to non-technical people, and those non-technical people can then relate to it. So these are the two classes of problems that we do or that we tackle as a consulting company. If people have an interest of learning more, or maybe are interested in inquiring us about availability or so, we're always available. You can just contact us at contact@think.com, and we'll be happy to provide more details about that. Other questions?
I had a question. I'll just ask it.
Go ahead.
So I was curious about the overall design of the system, and considering specific design decisions that you think are essential to enabling the overall generality or extensibility of the system, right? You talked about, for example, the ability to associate multiple projections or views with a particular object. That seems important. Or like, Richard Stallman about Emacs Lisp said that dynamic scoping of variables was important for extensibility because it could allow the insertion of middleware that wouldn't need to know about context being passed between the high and the low levels. And so I'm curious what design decisions you would say in Glamorous Toolkit are really key to making everything work together in this beautiful, very multimodal cross-tool way.
Well, so the core thing here is the current form of Glamorous Toolkit is one materialization of what we think the not reading of code should look like. So today, we're spending the largest chunk of our budget on one activity nobody really talks about. Now you have a reason to start talking about it. So that's the very first thing. And so if there's anything that we have done exactly that. But the second thing is, how did we do it? Well, just in a very short set of demos, I've already showed you many different kinds of combinations. So like a dozen or so, like different ways to combine things. Although I'm just combining them pretty much in the same way. There's like, I just have some panes that connect like that. And there are maybe different tools, with different tools have different views. In Coder, I might have a few ways to embed things in there so that there's extra logic that intersects there. But at the end, like what you're seeing here is actually, this is not, we're looking at the environment as a language, not as a set of features. And that's basically, this is the core thing that enables everything else. There is no, like, for example, right, if I start from somewhere, because there's no global menu. Why? Because a global menu implies it's like a global function. We don't want to have global functions. Things should be contextual. And so should the user interface be contextual? So we had to create a whole new language in which we can actually do that. But also this idea of, just a simple flow that we are having there allows us to work to tackle different kinds of contexts and decide when we want, what do we want to see. So the combination of these steps and how each step looks like is basically, it depends, like I'm choosing that one, right? So, but there are many other ways in which we can start combining those. So this language is actually not static, but it's combinable. So, so here's an example. This is actually an example, which is something we call a test. So an example is like an executable method that returns something. And here I have these self yellow things, but instead of a triangle, in this case, I have a dot. So if I click on that one, I get a new way of navigating. So I'm not embedding it now in place. I'm putting them next to it, right? And so if I do that, now I have a second one. So now I have three methods that I'm actually looking at the same time. Now, what's interesting about this is that what happens when I'm going to scroll here? So I'm scrolling a little bit on the left-hand side, and notice how those arrows go up and down. So this is basically likely not possible in any other environment today, because you need this whole scene to be rendered in a single representation. So this dot, which is inside this text editor, and the line that goes there, and all these panes and all the widgets, they have to be part of something we call the one rendering tree. So basically like a one DOM. One DOM that can be traversed in one pass. So there's no black box in our DOM. And because there's no black box in our DOM, then we can start combining this. So this is the other one. So on the one hand, we see the environment as a language, but on the other hand, we also believe that the environment, we should treat it as a language. So if you want this thing to be really expressible at its maximum possibilities, we also have to, the way we render things have to be equally flexible. And so this is why we built our own graphical stack, which means like the largest chunk of work that went into this, the latest release of Glamorous Toolkit is actually in creating these new graphical stacks so that we can express these things in new ways. So let's go, a little step further here. So if I'm going to expand these ones a little more, right? And if I'm clicking on this one, oh, I see that all of them, they're actually using the same thing. But now, because it's all in the same place, and this is an executable method, which means that I can get an object, which means that I can inspect it, I can then flip it, right? And I can just say, oh, what exactly are you there, right? And so this is an example of how, I don't know, I think this is a frame layout here, right? How do I compose a frame layout out of these little pieces over there, right? And I can go back and forth. But this little interface here, it's not really, like it's available, it's not pervasive yet. But it basically gives you an indication that the language that we have so far, while already expressive, has way more things that can be extended, like way more, there's way more creativity that can flourish on top of this platform for the time to come. So if there's anything, there would be these kinds of two things. The environment is a language and a very extensive or is very expressive graphical stack. So you can, to handle many different kinds of representations.
Yeah, that helps a lot. Thank
you. Okay, we're gonna, let's continue a few more. I see that there are a few other questions here. Are you also thinking about how moldable tools could be useful outside of the context of creating and understanding software itself? I'm thinking about how non-developers could profit from tools that they can adapt to their specific needs. Yes, so yes, we do think that this is a very interesting area. It's a very promising area, but we already have started from just this idea that you can actually have, imagine having a planning session with a non-technical or business person, where you can actually open an inspector and they can understand what you're showing them, like in a matter of seconds. It changes completely in all relationships that we're having with our software systems. And there's how much of the development process, for example, if you think about it, how much of the typical development processes are based simply on this idea that learning things about the inside of software systems is just expensive, right? And once that thing is not expensive, once you can have real deep conversations about your system, everything changes. So for example, just think about domain-driven design. People talk about ubiquitous language, and that's a great thing. But how do you know? How do you know? How do you know that this is actually the same language that is being used in the code as what you're drawing on the whiteboard? Because as soon as somebody draws something on the whiteboard, that whiteboard there is one of two things. It's either a wish or a belief. If the system doesn't exist, then it's a wish. And it's a good thing, because you say, well, this is how I would like it to look like. You have to start from somewhere, so that sketch is going to be great. But if the system already exists, well, that's a belief. What you're drawing on a whiteboard is a belief because it's what you think the system is. So we're thinking, beliefs are not a good basis for any decision making, and that shouldn't be used. And it's a system that should draw itself. So as soon as you're drawing your wish in a certain way, then you want your system to kind of represent itself in that way as well. And that alone, that completely changes the conversation. It changes how you plan, changes how you design, it changes how you interact with your users. So for example, if you're looking at our issue tracker, you will see that we, so also on the Discord sometimes, people will send bugs or pictures about bugs, about how the bug looks like from the inside. And sometimes if you're following our Twitter feed, you will see there pictures of bugs. And those pictures of bugs are getting retweeted. And that's crazy because bugs are supposed to be ugly. They're definitely not supposed to be marketing tools. And yet it's possible to change it like that. So yes, it would be great if users, end users would change their systems. I do think that we have a long way to go to get there. I definitely think that that's how it's supposed to be. This is how it was supposed to be, 50 years ago. Somehow we got astray in the meantime. But until then, this system here is a very practical solution for having completely changing the conversation that we're currently having. We can still dream futures on top of it, and we actually welcome this whole Glamorous Toolkit. It's free and open source, and we would like people to experiment with it and build new futures that we cannot imagine. But it's already practical, and we can already do a lot simply in the current form. So I hope that answers the question. So I suggest that we go for another maybe 5-7 minutes, and then we adjourn, but we definitely going to continue. So are there other questions?
Another question was about how difficult it is to add a new parser for a language, like Clojure, Python, or
how difficult it is to add a new parser. So how difficult, I don't know, let's see. So if you're going to go to Coder here, you're going to say here, I want to add a parser, and you say my parser here. And you say I will have a scanner here. This is still based on scanners. And I'll put it in my parser package. And if I say okay, then I basically have the start, and I can just start writing a parser. There's also a translation between, for example, if you have Antler, if you have Antler representations, if you have Antler parsers, there is a way this parser here takes that representation and actually generates. So one of the use cases that we're having with this parser, like with this language workbench, is transformations between languages, for example. So refactorings, but not only refactorings within language, but also refactorings between languages. So for example, we're using this for large-scale migrations between, I don't know, some legacy system and to some more modern language that maybe people can put easier on the cloud or something like that. But one other kind of transformation would be to say, well, here's a parser for a language written, it's expressed in Antler 4. And we're going to take that one and we're going to translate it into our parser. And yeah, it does the transformations that exist out of the box. They will probably handle 90% of it. And then with a few tweaks, you can also adjust that one. So that's basically how it is. The other thing to consider here is, if I take, for example, a JS parser back, and let's go back to our if statement over here. So if I have an if statement, and I'm going to say, one problem that we're having is that we want the cost of parsers to be small. So that means, where does the largest cost when creating a parser go? Well, where does the largest cost of creating anything in software goes? In debugging and understanding. So here, for example, right, if I have this production, I have a button which gives me a simulator over here. So which means that now I'm going to go and do, if I say if x equals 42, and at the bottom here, right, I can see I can see how, like how the parser works and what productions it hit over there. So it's like a debugging tool for writing parsers. So I hope that answers the question. Are there maybe one or two questions?
There was another, more philosophical. Like, what are the differences between Smalltalk dialects? Are all the same and just the UI is different? Or I guess Faro and GT is one and the others are something else.
So what's the difference between Smalltalk dialects? So Smalltalk is, Smalltalk is not a language, but it is an implementation of a language. So it's the incarnation of the language is the thing that you're seeing. So that the language is in the image, which means that every image is going to go and evolve basically differently. And then there were also different kinds of implementations even at the beginning. So mostly Smalltalk languages they share a lot of the core concepts. But there will be differences, a lot of differences, for example, at the level of the graphical stack. There will also be differences at the level of libraries, although the core libraries are going to be, to a good extent, very similar. So there are apparently more questions in the live sessions on Discord. Okay. So I think I saw one question over here was, how did we go from, if I have a playground and I open something, let's say 1 plus 41, how much is that? Okay, that's 42. How is this implemented? And if I alt click there, so I alt click over here, and I'm going to the meta site to see the implementation. So that works with alt clicking over there. Okay. Are there more questions? Maybe one more and we adjourn.
Just another sort of concrete, how would you do something? Can you go back to the keyboard shortcut thing, the little tutorial?
Keyboard shortcut. No, not that. It was here. So it's one of the recent questions that we addressed in the blog post. And you see it over there.
So you showed something that showed like that showed a bunch of the keyboard shortcuts in context, and I had a view of saying like, oh, you could do meta or left or something to do.
Yeah.
I just wanted to see that view again. So so I'm just kind of curious, like, let's say I had an idea for how to improve a projection of something. So for example, here, instead of meta left or meta right, I'd rather simplify that pattern to just a little caret, because that's what I'm, or whatever it is, How would I do that? How would I go about it? Like how would I know where to find the source code for this?
Yeah.
How
so
to
in this case,
change the view, so on.
Very cool. So in this specific case, this key binding knows how it's implemented. You see here, this is a text editor shortcut. So this is how what you would normally see. So you see here's the action, here's the shortcut, right? The action. But because the action is a block, and because the block knows how to present itself, we can already show you here, this is where it's implemented in this specific method over here. So if you now want to go and do this, so I don't know if you see the second window.
I know.
But basically, yeah, here if I take these initialize shortcuts, it will, like if you press this button over there, here it opens up the initialize method in GT source loader. And now if I go inside of it, and I have initialize shortcuts. So what just happened here, by the way, I was in a spotter and I had a class and I dived into the class, and all of a sudden here I have new kinds of searches that are happening in just for that class. So if I now go there, that's basically what I showed. Like this is exactly the same thing that I saw before.
Mm-hmm.
Make sense?
It does.
Does this address the question?
Well, I'm wondering, like this, the text representation of the shortcut has like this extended form, and I'm wondering if I wanted to modify that to, for example, like simplify it in some way, like you know, if I wanted to change meta left or meta right, that pattern to become a caret.
Just this
How
one
would
you mean? Right.
Yeah,
so
yeah,
we go to,
yeah.
Okay, so here basically we're seeing here we see key bindings, and I'm just looking at how this one is implemented. So this is a column list, and it has items, a shortcut, and I can see here on the first one, it says, well, it's a combination. So a shortcut has a combination, and that's what is going to be printed there. So if I look at that combination, so I'm now searching for that for the implementers of this combination. I can see, well, it's here in the editor shortcut or there. So basically, I see, okay, this is how it's being done, which means now that this is a getter. So which means that now I would need to go and look at the actual implementation. So now I can say, see, somebody has to pass it in. So what's that combination in there? Now, this is how I would go about doing it.
Interesting. Okay, that's helpful.
Right, this is a shortcut over here. Somewhere there's a combination, right? I can see it there, right? This is the object. Now I can see, oh, this is how it prints itself. How is this printing itself? Well, it simply does a print string. Okay, which basically means now that if I'm in this combination over there, and I look at that one, somewhere there is a print on method, and I can see how this one is like this. Okay, let's maybe change it to this. Right, I just changed it. And now if I go back to this one, I can see that there are square brackets over there.
Cool.
So, okay. But again, like just to maybe summarize, because this is maybe a good idea, a good example for how that one looks like. The idea is that we always start from the question and then we figure out what do we need. Sometimes the tools exist. If the tools don't exist, then we're going to go and build it. We're going to have sessions about how do we handle that specific use case. But it's always the process. This moldable development idea always starts from the question, and then you figure out what the path to action is. And so there is no predefined way of like this is how things should be done, but it's rather you have a set of patterns, you have a set of and a set of tools and operators that you can then combine in many ways. And you should approach this problem exactly like how you would approach learning any other language. If you approach this environment as, oh, I want to learn how, like all the features, it's going to appear very, very daunting because there's so many different possibilities. But because that's not how we're building it as a language that is uniform, and you know, once you learn, you go into it and take a few concrete scenarios and go through them, but always starting from a very, very specific context, not a generic problem, because it's very hard to fake the importance or the value of context. It's very hard to fake. So don't. Start from a problem that you really care about, and then learn how, or basically think what's the language that gets me from my question to the answer. And that's because that's basically how we are thinking about it. Sometimes maybe some pieces are going to be missing because this is all, you know, we're still learning what the whole space could look like, but we can cover a lot. So, you know, like there was this question about, how do we fund ourselves? We fund ourselves through very concrete projects, very concrete problems that we actually have to solve, and we have to solve them faster than, you know, like in real time. We have to be there and deliver value. And so what Glamorous Toolkit is, like all of those projects are validation for the current shape of Glamorous Toolkit. We're literally, and we are only solving those problems with these tools because we are a little bit stubborn. But again, like this, we didn't create this environment in a vacuum. It was literally built to help us solve very, very concrete problems. I'm sure that, you know, once people will start figuring out that this is a real area, others will, you know, go and build other means of expressions, other kinds of languages. But it's guaranteed that the future of development is going to be a language and not a set of tools. So thank you very much. Let's continue. Thank you very much also for the enthusiasm and for all the interactions, and let's continue those. And we will be having more of these live sessions.